Hello everybody, welcome to this short presentation on quadratic equations and its applications. In this short video, we are going to solve quadratic equation using factoring method or using zero product property. Meaning of that is, when you factor any quadratic equation to this form, say for example ax plus b times cx plus d equal to 0, then by zero product property, either ax plus b equal to 0 or cx plus d will be equal to 0. And from each of these, we'll be able to find the value of x. So we are going to use that technique for solving quadratic equation. Second type of example that we work will be solving quadratic equation using quadratic formula. So in this one, for any quadratic equation in the form ax squared plus bx plus c equal to 0, the roots are given by the formula x equal to negative b plus or minus the square root of b squared minus 4ac, everything divided by 2a, and this formula is quadratic formula. Third one will be solving quadratic equation using completing the square method. So on the left hand side, we try to make a complete square and solve the quadratic equation. The fourth type of example will be on the roots of the quadratic equation. So in this one, what we need to know is if alpha and beta are roots of quadratic equation, then the quadratic equation will have this form: x squared minus sum of roots multiplied to x plus product of roots equal to 0. And the last type of example we'll do, and those examples will be based on solving the real world problem using quadratic equations. So we'll solve some application problems here. In this first example, we are asked to solve the quadratic equation 2x squared plus 3x minus 2 equal to 0 by factoring method. Since the left hand side is a second degree trinomial, we use sum and product method to factor this. So we multiply the leading coefficient and the constant term. So 2 times negative 2, that will be negative 4. Now from negative 4, we have to find two numbers whose product is negative 4 and sum is equal to the middle one, which is positive 3. So the factors will be 4 and negative 1. So we can rewrite the middle term using 4 and negative 1. So it will be 2x squared plus 4x minus 2 equal to 0. So we split the middle term to these two. Since we have 4 terms on the left hand side, we can factor by grouping. In the first group, we have a common factor of x, in fact 2x, so it will be 2x multiplied to x plus 2. In the second group, we have a common factor of negative 1, so it will be negative 1 times x plus 2 equal to 0. We still have these two groups, and in these two groups there is a common factor of x plus 2. You can factor that out, so it will be x plus 2 times 2x minus 1 equal to 0. So we factored the left hand side completely, and we can now use the zero product property. So we can say either x plus 2 equal to 0 or 2x minus 1 equal to 0. From the first, you get x equal to negative 2, and from the second, we get x equal to, if you add 1 on both sides, 1, then divide by 2, so 1 over 2. Therefore, the two values or two roots of this quadratic equation are negative 2 and positive half. In this problem, we are asked to solve the quadratic equation, which is written in this form. If you look at the left-hand side carefully, it's a trinomial. It's a second-degree trinomial. So we can factor the left-hand side. From 15, we have to find two numbers that will give you negative 8. So the factors are negative 5 and negative 3. So when we factor this, it will be 1 plus 2 over x minus 5 and 1 plus 2 over x minus 3 equal to 0. You can simplify these factors a little bit, so it will be 2 over x 1 minus 5 negative 4, and the other one is 2 over x minus 2. So you have two factors multiplied together to 0. If you use 0 product property, then you can say either 2 over x minus 4, okay, 2 over x minus 4 equal to 0, or 2 over x minus 2 equal to 0. From the first part, you get 2 over x equal to 4. If you cross multiply, 4x equal to 2. And divide on both sides by 4, x equal to half. Similarly, from the second, if you add 2 on both sides, you get 2 over x equal to 2. Cross multiply, 2x equal to 2. And divide on both sides by 2, you get x equal to 1. So therefore, we obtain two values of x again. X equal to 1 over 2 and positive 1. So although the equation looks little complicated, it's not that complicated, because your left-hand side is simply a trinomial with the leading coefficient 1. So whenever the leading coefficient is 1, whatever number you obtain here, you can directly use these numbers to write the factors. And we solve here by factoring. Now, third example. Here also we are asked to solve this quadratic equation, in fact a cubic equation, using factoring method. So we have a cubic equation, x to the third minus 5x squared plus 6x equal to 0. We need to factor the left-hand side, and when you look at the left-hand side, there is a common factor. Okay, first we factor the common factor, which is x, then we get x squared minus 5x plus 6 equal to 0. Inside the parenthesis, there is a second degree trinomial, which can be factored using sum and product method. So from 6, we have to find two numbers. From positive 6, we have to find two numbers whose sum is negative 5. So it is negative 2 and negative 3. So once we factor this, we get x times x minus 2 times x minus 3 equal to 0. So from here you can say either the first factor is 0, or the second factor is 0, or the third factor is 0. From the first you already have x equal to 0. From the second we get x equal to 2. And from the third we get x equal to 3. Since this is a cubic equation, we obtain 3 values of x, and these 3 values are 0, 2, and 3. So that is the end of the first type of equation, that is solving equation by factoring method. In this example, we are asked to solve the quadratic equation using quadratic formula. So for any quadratic equation, ax squared plus bx plus c, the quadratic formula is x equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So first, by looking at this equation here, we'll find the values of a, b, and c. So here, in place of a, ax squared, so that is 2. Then bx, so b is equal to 5. Then we have plus c here in this equation, and in place of c we have negative 3 here. Now we use our equation, or we use our formula, x equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So we get x equal to negative b, so it is negative 5 plus or minus the square root of b squared, 25, minus 4, a is 2 and c is negative 3, divided by 2a, 2 times 2 is 4. So x equal to negative 5 plus or minus 25. Inside the square root we have 25, negative and negative positive, and 4 times 2, 8 times 3, 24. So 25 plus 24, it's 49. And square root of 49 is 7, divided by 4. So we get x equal to negative 5 plus 7 over 4, or x equal to negative 5 minus 7 over 4. That is x equal to 7 minus 5 is 2 divided by 4, that is half. Or from the second we get x equal to negative 5 and negative 7, negative 12 over 4 is negative 3. Therefore the two values of x are x equal to 1 over 2 and negative 3. So this process of solving equation by using this formula here is solving quadratic equation using quadratic formula. All we need to do is we need to find the values of a, b, and c from the given equation and plug in back here in this formula, that is the quadratic formula, simplify and obtain the result. I hope this is helpful for you. Okay, third method of solving quadratic equation for our video is using completing the square method. Let's begin with our equation. We are asked to solve 4x squared minus 2x plus 1 equal to 0. So when equation like this is given to you and you are asked to use completing a square method, First, we try to make the coefficient of x squared as 1. So divide throughout by 4. X squared minus half x plus 1/4 equal to 0. That is the first step. Next step, you move the constant to the right hand side. So we move 1/4 to the other side, so it becomes negative 1/4. Now in this step, we have to find half the coefficient of x. Coefficient of x is 1/2, so half of 1/2 is 1/4. So we add the square of that 1/4 on both sides. By doing that, the left hand side will be a complete square. The easy way to do that is, from the first you just write x, from the second term just write the sign, and from the third one just write the quantity without squaring, that is 1/4, and write everything as a square. So x squared minus half x plus 1/4 square is same as x minus 1/4 square. If you FOIL this, x minus 1/4 times x minus 1/4, we get x squared minus half x plus 1/4 square. On the right hand side, we simplify the fraction. You have negative 1/4, then plus 1/4 square, 1 squared is 1, 4 squared is 16. In order to add this, we make a common denominator of 16, so we multiply here by 4. So 16 is the common denominator. In the numerator, we have negative 4 plus 1, which is equal to negative 3 over 16. Negative 3 over 16. Now in this step, we can take square root on both sides. And when you take a square root on both sides, we take plus or minus theorem. X minus 1/4, because square and square root will undo each other, equal to plus or minus. Square root of 3 is simply square root of 3, but there is negative 3, so it will be square root of 3i. Divided by, in the denominator, square root of 16 is 4. This implies x equal to, add 1/4 on both sides, 1/4 plus or minus square root of 3 divided by 4i. So it's a complex number, and we write as a and bi form, which is already there. So we have two values of x. Therefore, x equal to, your first value is 1/4 plus square root of 3 over 4i. And the second value is 1/4 minus square root of 3 over 4i. These are the two values of x for the given equation. And the process we use here is called the completing square method. Okay, in the sixth example, we are asked to find the value of k if the roots of this equation are reciprocal of each other. So meaning of that is, if we know the first root, second root is the reciprocal of that. But we don't know what are the roots. So I'll consider the roots as, let the roots be alpha and 1 over alpha. Okay, these are the roots. So the equation will be that is, the equation with these two roots will be x squared minus the sum of roots, alpha plus 1 over alpha, x plus the product of root, alpha times 1 over alpha, that's 1, equal to 0. So if alpha and 1 over alpha are the roots, the equation will look like this. But this is the equation given. So let's compare these two equations. So comparing with so in order to compare, the coefficient of the leading coefficient, the coefficient of x squared, or the leading coefficient must be 1. So we divide throughout by 6. It will be x squared minus 13 over 6x plus k over 6 equal to 1. So when you compare, you can see that k over 6 is equal to, hold on one second, k over 6 equal to 0, because 0 divided by 6 is 0. So now by comparing, what we obtain is k divided by 6 equal to 1. So if you cross multiply, k equal to 6. That is all we need to find. We are asked to find the value of k. So meaning of that is, if you plug in k equal to 6 in this equation, it will be 6x squared minus 13x plus 6. And when you solve that equation, you'll obtain two roots, and those two roots will be reciprocal of each other. And whatever root you obtain, that is alpha, and the second root will be 1 over alpha. The last and the 7th example for this video is the application of quadratic equation. In this problem, it is said that the sum of reciprocals of two consecutive even numbers is 7 over 24. Find the numbers. So we have to find two consecutive even numbers. If we know the first even number, the second or the consecutive will be 2 more than this. So it will be x plus 2. So that's our first step. We consider the numbers. Let the numbers be x and x plus 2. Now, the question says sum of the reciprocals. Reciprocal of x is 1 over x. Reciprocal of x plus 2 is 1 over x plus 2. And when you add this, the result is equal to 7 divided by 24. Note that in this equation, x cannot be 0 and x cannot be negative 2. Because if x is 0 or x is negative 2, the equation has no solution. Also, LCD for this one will be, when you look at it, it's a product of the denominators without repeating them. So it is 24x times x plus 2. So if we multiply throughout by 24x times x plus 2, we can easily get rid of the fraction. So if I multiply the first one, 24x times x plus 2, multiply the second one, 24x times x plus 2, multiply the third one, 24x times x plus 2. If we do so, we'll be able to cancel the denominator. In the first one, we'll be able to cancel x. In the second one, we'll be able to cancel x plus 2. In the third one, we'll be able to cancel 24. So let's see what is remaining. In the first term, we have 24 times x plus 2, plus in the second one, we have 24x equal to, on the right hand side, we have 7x times x plus 2. If we distribute 24 and combine like terms, it becomes 48x plus 48 equal to, on the other side, or the right hand side, if we distribute 7x is squared plus 14x. On simplifying, we get 7x squared minus 34x minus 48 equal to 0. So this is a second degree trinomial. We can factor this by using sum and product method. So we multiply 7 times negative 48 7 times negative 48 is negative 336. Now from negative 336 we have to find two numbers whose product is negative 336 and sum is the middle term, that is negative 34. So these two numbers are negative 42 and positive 8, because 8 times negative 42 is negative 336 and 8 minus 42 is 34. So you can rewrite that. Rewrite the middle term using those two numbers, 7x squared minus 42x plus 8x minus 48 equal to 0. We factor by grouping. In the first group we have a common factor of 7x, so we get x minus 6, plus in the second group 8 is the common factor, x minus 6 equal to 0. Further, it can be written as x minus 6 multiplied to 7x plus 8 equal to 0. Now we can use zero product property to solve this. So we can rewrite this as either x minus 6 equal to 0 or 7x plus 8 equal to 0. From the first we get x equal to 6, which is the even number as we are looking for. And in the second we get x equal to negative 8 over 7, and this is not even. This is not even, so that is not something we are looking for. So the only answer that we get is x equal to 6. We want two numbers, x and x plus 6. So x plus 6, x plus 2, x and x plus 2. So x plus 2 will be equal to 6 plus 2, that is equal to 8. So that is the second number. So you can write therefore numbers are, or the even numbers that we are looking for are 6 and 8. So these are the two numbers required. You can also check your answer. That is, what you have to do is you have to take the reciprocal of 6, which is 1 over 6. You take the reciprocal of 8, which is 1 over 8, and add them together to see whether you will get 7 over 24 or not. If you get 7 over 24, these two numbers that we obtain here are correct. And in fact, these two numbers satisfy the given equation. So with this, we completed this short video on quadratic equation or solving quadratic equation and their application. I hope this video is helpful for you. Thank you for watching.